So now we want to take a closer look at the topic of perforation and examine the various methods available to implement perforations and how to easily manage all of this within the plugin with just a few simple clicks. Let's dive straight into it. So we'll start with a blank document. We'll set the size to 570 by 1000 millimeters. That's a typical sheet size for DTF material, and we'll use that here for our example. We're inserting a logo now, and we want to place and distribute that logo across the page, for example, as a small neck label on the garment, positioned and scaled to fit the neckline. First, as part of the DTF workflow, we'll open the Saga DTF plugin and bring in the brand marks plus the QR code, arranging them on the layout in the required sizes and positions. As you can clearly see and observe, intermediate registration alignment reference marks are also being generated, and along the outer edge, naturally, this is given as a small reminder, because the work table of the DTF Multicut system can only accommodate a maximum total length of just a little over 800 millimeters in a single setup or one continuous run. It can be used this way, and everything that exceeds that limit must be set off with visible interim markers. Right, so now we're going to look at perforation. We can trigger those perforation functions in a number of different ways. For example, with software commands via the front panel controls or through an external controller or bus. Not every one of our devices supports hardware perforation natively though, so that capability varies by model depending on the exact firmware revision. That's the first thing we'll examine now. So to do that, we'll take the logo, select it and highlight it, and then we're going to distribute it across the page using both horizontal and vertical guidelines. We'll set a fixed spacing of 8 millimeters between each logo and keep a clear margin of 10 millimeters at the page edge. In other words, every logo will sit 8 millimeters from its neighbors and none will be placed closer than 10 millimeters to the border, ensuring an even balanced layout. Then we'll generate the file, and you can already see how nicely the logos are distributed, and you can also see, oops, that's not what we wanted. You can already see here that lines have been generated and that parts are slightly clipped beyond the edge, so that in the end the logo can be cleanly cut out, so that at the final stage, when we trim or separate it, the emblem stands out with a neat, precise edge and no unwanted background showing. We want to make sure it doesn't fall out now. It should be an arc, for example, with a neck label that stays attached. That's why this area needs to be perforated. So we go into the cut layer and now select all the pads here, the cut lines, marking them so the perforation and the remaining little bridges are clearly defined and the label will stay connected. Switch to the display mode and now choose the color. And now this becomes really important. We select the swatch labeled CMYK Cyan and assign that exact color to the path. So the path uses that precise Cyan. And with that, well, everything is actually taken care of. We can then, as usual, using this button here, create the PLT file, and we'll just call the whole thing test plot for now, so that it can be reviewed and printed later or imported into the plotting software if necessary. But for our purposes, that name will be sufficient for now, and that completes this little setup step for the moment, and we can move on now. Hardware perforation. Well then. And in just a moment, we'll also take a closer look together at the device's display to show step by step exactly how to change the setting, walk through each option, and confirm the new configuration so it switches mode. Just as a reminder, Cyan is the designated trigger for all devices that are capable of supporting hardware perforation. We no longer need to adjust anything within the software itself here, so there's no need to set the spacing of the interspaces. We'll do that on the machine's hardware perforator, and we'll go over it again on the actual device in a separate video. So now we're looking at the display on the DTF Multicut Pro, and here in the settings menu, we select Perforation Mode and step through the available options so you can see exactly how the parameters are set on the device. Right now, we're going to step through the settings. If we want to control the perforation from the software, that is via the plugin and by selecting the color cyan, then here we can choose the option labeled off file. So the cutter applies it at output instead of embedding those marks in the artwork, which gives us flexibility and avoids accidental printing.
though the perforation simply isn't being driven or controlled at all anywhere in the workflow except only inside that specific PLT file, which is precisely why it's marked as file in the system configuration settings. The perforation mode is activated by what we control using the color Cyan within the plugin. This can be individually controlled for every single stroke, every line, every vector, and every circle directly within the software. We can then set the blade up force here in the control panel. That's essentially the amount of force the blade should apply when it needs to move upward during the cutting cycle. For this example, we'll enter 0 and 27 millimeters and 1.5 millimeters, which is what will lift the blade reliably. These are the parameters you can set however you like, but with values of 27 and 1.5, we'll already be getting good consistent results, very reliable performance, and running pretty smoothly.